So in this example, we're asked to find all angles theta in the interval from 0 to 360 degrees, such that cosine of theta is equal to negative 0.8523. So the way to begin, if we want to solve for the angle theta, we're given the output of the cosine function, in this case negative 0.8523. We want to find the angle, the input. Then we need to use the inverse cosine function on the calculator. So the idea here is, in order to solve for the angle theta here, we do inverse cosine of this given value, 8523. And I grabbed my calculator, here it is. So if we do, you're going to need to press second on this calculator, and then cosine function, negative 0.8523. This gives us 148. So theta is approximately 148 point, if we're rounding to the nearest hundredth, this will be 0.46 degrees. Okay, so there's one solution. Now the thing is, if we're finding all angles, this is where it gets a little bit tricky. So we have to think about in which quadrants would we expect to have a solution. So keep in mind, cosine is associated with the x-coordinate, right? Cosine theta is equal to x over r. We use that XYR definition. And so cosine is positive when x is positive. And I guess here we want cosine to be negative. So cosine of theta is negative when the x-coordinate is negative. So we need to think about the quadrants in which the x-coordinate is negative. And just real quick, cosine theta is negative when x is negative because cosine is equal to that ratio x over r, and r is always positive. So the value of cosine theta x over r is only negative when x is negative. Negative up here. So the quadrants where x is negative, that would be quadrant 2 and quadrant 3. We should expect solutions in quadrant 2 and quadrant 3. 148 degrees, so that's bigger than 90 degrees, but less than 180 degrees. So 148.46 is in quadrant 2. That's our quadrant 2 solution. Quadrant 2, we have theta equals 148.46. So the question is, what is the solution in quadrant 3? That's what we need to figure out. And so this is where reference angles come into play. So if we draw the solution that we have at this point, and you don't need to worry about making it perfect, just have it lie in quadrant 3. This angle right here is 148.46 degrees. So the reference angle, lost my red marker, here it is. The reference angle for that solution would be this angle here. So the reference angle, theta r, is 180 degrees. Take away the blue portion, right? 180 degrees, that's this straight angle here. If we subtract the blue portion, so if we subtract I keep my color scheme, 148.46, then that'll leave us with just the red portion. So it turns out that theta r, let's see if I do 180 minus that, we have 31.54. Now, in order to find the quadrant 3 solution, I'll draw another little XY plane over here. Take that same reference angle, but set it up to give us a solution in quadrant 3. So put the reference angle, 31.54, set it down in quadrant 3. So that means that this full rotation around to this point, our quadrant 3 solution, will be 180 degrees, that's this much, plus the 31.54. So our quadrant 3 solution is 180 degrees plus 31.54. And so that gives us our second solution, which is, wouldn't this be 211.54? And there's our two solutions.